Okay, so now we're back to day 2 of stoichiometry. What you learned about in the last lesson is you learned how to do what we call a mole-mole conversion. That's what we were talking about with recipes, how to go from the number of moles you have of one thing to find the number of moles you need for the other. So for example, we talked about how we always have to start with a balanced equation. So we'll take 2 sodiums plus chlorine. Got to remember, chlorine's a diatomic, so it's got to have that 2 there. That will make 2 sodium chlorides. And when we put sodium chloride, we got to go back to that other chapter where sodium's a +1, chlorine's a -1, so we put them together as NaCl. So every stoichiometry problem starts with a balanced equation. What you did in the last lesson is you were given moles of one of your reactants or products. So in this case, let's say 1.71 moles of sodium. And you were asked to find how many moles of chlorine would be needed to react with that. So, what you did to solve this, very straightforward. First thing, had to draw a cross. Whenever you do these crosses, you know that your given is going on the top left. Then we came down here, put the unit of our given on the bottom right, and then the unit we're looking for up on the top. Then to fill in our numbers, we have to use the mole ratio. That's the coefficients from the balanced equation. So I very simply say, okay, what coefficient do I have next to chlorine? Go up top and it's a 1. What coefficient do I have next to sodium? Go up to my equation, it's a 2. So to calculate this out, 1.71 times 1 divided by 2, I get 0.855 moles of chlorine. That was the last lesson. Here's the problem. The problem is there is no way in my lab I can actually measure out 0.855 moles of chlorine. I don't have a balance. I don't have a piece of equipment. I don't have a device to measure that out. So what we're going to do today is we're going to take that one step farther. So the next step is taking these mole-mole problems and we're going to make them into what's called mole-mole gram. Because as you know, we can measure grams. We have balances. It makes life easier. So let's go back to the exact same problem you were doing before. Let's say I have 1.71 moles of sodium, and I want to know not how many moles of chlorine I can make, but how many grams of chlorine I can make. We're still doing dimensional analysis on this, although I am going to show you another method of doing this at the end of this video. So if dimensional analysis is not your strong suit, there is going to be another option. So give this a try, stick with it. I'll show you the second method. You pick which one is best for you. So using dimensional analysis, you know how this is going to work. We're going to draw a cross. We're going to do what we've always done. In my given, 1.71 moles of sodium up there. Okay, moles of sodium down there. The catch here is that I can't go from moles of sodium to grams of chlorine. I can't make that direct jump. I'm going to need a middleman. Think about it this way. If you have a recipe that says you need 1 cup of flour plus a whole bunch of other stuff that we're not going to worry about right now, but 1 cup of flour will end up making 60 cookies. Okay? If I told you that you had 3 bags of flour, you can't immediately tell me how many cookies you're going to make. You can't. You don't know how many cookies that's going to be until you find out one thing. The one thing you have to know to be able to solve this is how many cups are in a bag. Okay? That's really what we're talking about with this right here. In order to figure out moles of sodium to grams of chlorine, we have to have a middleman. And as we learned before, the ultimate middleman is the mole. So look again at the name of these problems, mole, mole, gram. That tells me how my conversion's going to go. So my first step is I'm going to go from moles of sodium to moles of what I'm looking for, which is chlorine. This is exactly what you did before. I go to my balanced equation, which we had on the last screen. There was a 1 in front of my chlorine, there was a 2 in front of my sodium. But I'm not done. If I stop right here, I'm the same place I was before. I want to go one step farther. So now I'm going to convert my moles of chlorine into grams of chlorine. And you guys know how to do this at this point. Okay? For every time you have grams and moles, Your mole is going to be a 1. That's what the molar mass gives me. And the grams is going to be found on my periodic table. So I go to my periodic table and I look up chlorine. Chlorine is 35.45. I have 2 of them, so my mass is 70.9. So then as I calculate, I do the same thing I always do. I'm going to take my 1.71 times my 70.9, get an answer for that, divide it by 2 because that's what's on the bottom. My answer for this problem is 60.62 grams of chlorine. Now, for the record, you don't have to do it in one long string. If, for example, you decided that you wanted to do 1.71 moles of sodium, and then you would go from moles of sodium to moles of chlorine, just like you did before, 1 of those, 2 of those, calculate it out, 0.855, and then you wanted to do a second cross. 0.855 moles of chlorine is going to be going from moles of chlorine to grams of chlorine. 1 mole, go to my periodic table, 70.9 grams. What do you know? The answer is exactly the same. There's nothing wrong with that. Whether you do this in 2 steps or in one kind of giant dimensional analysis problem is totally and completely up to you. Mathematically, it is the exact same thing. So those are your mole-mole gram problems. Again, you look across the top of your dimensional analysis and look what I've got. Mole, mole, gram. And you know, now you're getting another wrinkle. Here's your new wrinkle. Your new wrinkle is, I can't really measure moles in a lab. I said that before. So in this problem, I was starting with moles. I can't start with moles. I don't really measure that way. So if we're talking real world lab, what am I actually going to use if I'm in a chemistry lab? You've got to be able to use grams. Okay? Have to be able to use grams. So let's say, we'll stick with the same equation here because it's kind of a simple one. We're talking again about making salt. 2Na plus Cl2 makes 2NaCl. And a happy face just because, you know, hey, you're watching a video. If this problem was given to me, let's say it said 12.3 grams of sodium is equal to how many grams of NaCl? Whoa, that's the ugliest Cl ever written. Let's try that again. Cl. So if I'm given this, hey, can you tell I'm doing this in school? There's the bell. If I'm doing it like this, I'm going from grams of sodium to grams of NaCl. These problems, wait for it, are called gram, mole, mole, gram. That's what you need to remember. Gram, mole, mole, gram. Gram, mole, mole, gram. Gram, mole, mole, gram. Gram, mole, mole, gram. If you're now picturing like a mole wearing an old grandma outfit, good. Gram, mole, mole, gram. Remember that. You need to know that order. That order makes all of these problems easier. Okay, what was it again? Oh yes, gram, mole, mole, gram. You got it? Are you bored yet? Good. So, here's how to do this problem. The problem we were looking at said we had 12.3 grams of Na, and we wanted to get to grams of NaCl. Again, you need to remember these problems are gram, mole, mole, gram. So we're going to set it up. Yes, it's going to be a long one. So we're going to start with my given, 12.3 grams of Na. I know grams of Na has to go down here. But again, just like we were talking about before, you can't go from grams of one to grams of another. If we go back to my flour and cookies example, if I asked you how many, if I had 3 bags of flour, how many plates of cookies can I make? You can't answer that until you know how many cups are in a bag and how many cookies are on a plate. That's really what this is. Moles are always the middlemen. So we're going to go first from grams of sodium to moles of sodium. We have to. We cannot compare 2 elements without having moles. I go to my periodic table. The molar mass of sodium is 23. Now I want to point something out before we go further. That is a 1. If you look at the balanced equation we are working at, the coefficient that's in front of sodium is actually not a 1, it's actually a 2. But this number right here has nothing to do with the balanced equation at all. This is solely the molar mass. which we'll come back to here in a minute when I show you the second method. So this gets me from grams of sodium to moles of sodium. So now I'm going to keep going. Moles of sodium is up top. It's got to go on the bottom. The next one I'm going to make, moles of NaCl. I've got to go from one chemical to the ending chemical. So this is when I go to my balanced equation and I use the coefficients. There's a 2 in front of NaCl. There's a 2 in front of Na. Could you write 1 and 1? Sure. It's the exact same thing mathematically. Then, this is my mole ratio, by the way, M ratio. Then I'm going to do my last step. Okay, my last step is, you know my moles have to be down here, moles of NaCl. Now I'm going to end up with my grams of NaCl. So again, I go to my periodic table, 1 mole of NaCl. Okay, again, it's 1. I don't care that it's a 2 down here. It's 1 because we're talking about molar mass. If I add up a sodium and a chlorine, is 58.45. So now, the really fun part, if that's not enough, you got to calculate it. So to calculate it, you always have to multiply across the top. 12.3 times 2 times 1 times 58.45. Then divide by the product of what's on the bottom. Remember, if you're putting this in your calculator, put these things right here in parentheses. It will make your life much easier. That way you don't have to worry about order of operations. So the answer that I end up getting for this problem, I'll sneak it over here on the corner, is 31.26 grams of NaCl. With 12.3 grams of sodium, that's how much NaCl I can make. The reason I told you had to remember this gram, mole, mole, gram is I know this looks complicated, but look at the problem. Gram, mole, mole, gram. That's the order across the top. Gram, mole, mole, gram. When you look at that gram, mole, mole, gram, I'll do you one better. You can actually split it. If you kind of draw a line right here, these two are going to be the chemical you're given. These are going to be the chemical you're looking for. So no matter what kind of stoich problem you've got, if you can remember gram, mole, mole, gram, you can do any of them. Any of them. Doesn't matter which one, you can do them all. For example, if I said you have 12 grams of sodium, okay, how many moles of chlorine will you make? If I look at my problem, I'm starting with grams. So I start right there. I'm ending with moles. I end right there. So I know that this problem is going to look like this. Gram, mole, mole. Because that's what I can see in this little order. Okay, gram, mole, mole, gram, mole, mole. If I gave you 1.2 moles of sodium and asked about grams of NaCl, again, if I remember this gram, mole, mole, gram, I look at where I'm starting, mole. I look at, here, let me erase those blue arrows so they don't confuse you. I look at where I am ending, grams. So this one would be the same amount of steps, but this one would be a mole, gram problem. It's always following this pattern. You just have to find your starting and your ending point. So, quick summary. We're talking gram, mole, gram problems. Okay, these are full stoichiometry problems. You have 3 steps. Step 1, you have to balance your equation. Without a balanced equation, nothing works. You cannot put a bag of flour, a carton of eggs, and a shot of vanilla and expect to get a cookie. It's going to be nasty and it ain't going to work. Same is true in chemistry. Number 2 is you've got to find your start and stop. Okay? You have to find out where you are starting and stopping in this whole chain of gram, mole, gram. The next video is I'm going to give you an alternative method to doing these as dimensional analysis problems. So if this is like your Achilles heel and not your best friend, watch the next video, check it out, see if the next method works for you.